Hi everyone, how are you? This is Mari Carmen and I am translating a tutorial created by Gabriela Carita. In this tutorial we will talk about monitoring floods with Sentinel-2 and Landsat 8 images in QGIS 3.0. We know that the flood occurrence has increased due to the changes in the climatic variables and the intervention of humans in natural streams. With remote sensing and satellite images, we can determine potential flooding areas using QGIS 3.0 and the semi-automatic classification plugin. For this example, the study area is the Ucayali River near to the Iquitos city in Peru. We have downloaded the Sentinel-2 and Landsat 8 images. To do this, we use the SCP plugin or semi-automatic classification plugin, and to install the plugin, you only have to go to Plugins, Manage and Install Plugin, and look for Semi-Automatic Classification Plugin. And then you click on Install Plugin, and that's all. So for this case, we have already downloaded the Landsat 8 images and the Sentinel-2 images. I am going to add the bands of the Sentinel-2 image. Okay, so now here we have the Sentinel-2 images and the Landsat 8 bands. If you want to download the images, you have to go to the SCP plugin, then Show Plugin, and here you have an option that says Download. You need to use your login data for the Sci-Hub of Sentinel or the Earth data from NASA if you want to download Landsat images. Then you can search the image that you're trying to find, and you can use this option to find images, and you can use this other option to set the area in the map. For instance, if I wanted to find this area, I just have to select the area, and then you're going to start seeing these coordinates in here. Okay, so in this tutorial we are not going to download images, but this is how you can do it. And you can find the images in the article posted in Hatari Labs. So what we are going to do is to calculate the NDVI, or the Normalized Difference Vegetation Index. To do this, we can do it with the band calculator of the SCP plugin. Before that, we are going to create a band set. I'm going to find, these are my Sentinel bands. And I'll select all of them. Okay, so now here we have the Sentinel-2 bands. We can choose the quick wavelength settings. And here we have, for QGIS, the name of the band will be this number. So the number on your left side. For instance, band 3 will be band 2, band 5 will be band 4. We are going to be using band 8, band 4, and band 3. And then we can create another band set for Landsat, for the Landsat images. So here we have all the Landsat images. And now we can create a virtual raster and here we have the virtual raster of the study area. So with these numbers we are combining the bands. We combined band number 7, number 3, and number 2. Of the band set 1. And here, band 7 is the near infrared one, or band 8 in Sentinel 2. Then band 3 is band 4 in Sentinel 2, which is the red region, and band 2 is band 3 in Sentinel, which is the green region. And we can do the same for the second band set. But for the second band set, it's a Landsat image, and we have to create a different combination. And here the near infrared band will be band 4, no, the near infrared will be band 5. Band 5, then the red region 4, and the green region 3. So we're going to do 5, 4, and 3. I am going to move this virtual Landsat to Landsat 8. Okay, so now you can see the false color image with a Landsat satellite image. And we can compare it to the Sentinel 2. We can see that there's more clouds in the Landsat 8 image than in the Sentinel 2. We can also see that the resolution is better in the Sentinel 2 image than the one in the Landsat 8. Okay, so now we can calculate the NDVI of each image. To calculate the NDVI, we are going to open the Raster Calculator of the SCP plugin. So we can go to Band Calc. And here we have all the bands. So let's do the Sentinel 2 first. The Sentinel-2, the formula of NDVI is the difference of the near-infrared and red regions divided by the sum of the near-infrared region plus the red region. With Sentinel, we know that the band for near-infrared is number 8. So we have to find it in here. The Sentinel-2 images start with clip T1. So here we have band 8. And then minus band 4. Divided by the same bands, but instead of 8 difference, we are adding them. Then we click on Run, and this is Sentinel. This will be the NDVI Sentinel-2. And now here we have the NDVI of Sentinel-2. I'm going to move this to the other group. Okay, and now we're going to do the same, but for Landsat. We're going to open the Raster Calculator, and we're going to select the near infrared band, which is number 5 for Landsat. Here we have band 5 for Landsat minus band 4 divided by the sum of both of them. And run. I'll save it in the Landsat folder. Okay, so now here we have two NDVI layers, one for with the Landsat 8 images, NDVI Landsat 8, and NDVI Sentinel-2. Now we're going to change the properties so we can see the color of each NDVI. We go to Properties, and we are going to be using single band pseudo color. The color ramp that we will be using is this one, purple, blue, green, and we can apply to see how it goes. We can invert colors, and now we can see the floating areas in green. We're going to copy style and paste it to the other NDVI. Okay, so now we have the NDVI of both images, and with the NDVI we can identify the potential flooding areas. The NDVI values closer to 0 or negative will represent the regions with water. With the band calculator, we will show only the NDVI values greater or equal to 0. No, not greater, less than or equal to 0. Okay, so we're going to open the raster, the SCP raster band calculator, which is in here. And we are going to create expression. So we're going to be using the NDVI for Landsat 8, the values that are less than or equal to 0. And we're going to click on Run. We are going to save it as flooding areas Landsat 8. Okay, so it doesn't matter if it only says 0, we can change the properties. We are going to be using single band gray, then change it to white to black, blending mode will be darkened, and then try to apply. Okay. So now we erase the minimum and we only left the maximum value of 0. We use the darken blending mode. And let's use a blue color. We can also use the single band pseudo color. Okay, so here it is. The potential flooding areas are the ones that are in here. And now we're going to do the same with the flooding areas of Sentinel-2. So we go to SCP and then band calculator, and instead of using the Landsat 8, we're going to be using the Sentinel-2 one. And we click on Run. And this will be here in Sentinel. So here you can see that we have two rasters, one the flooding areas with Landsat 8 and the other one the flooding with Sentinel-2. And now we can compare them. I'm going to turn off this one. Here we have Landsat 8 and here we have Sentinel-2. So as you can see, the Sentinel-2 cover a bigger area than the Landsat 8. The white areas are the areas that are that have water on them, and here we have Landsat 8 and Sentinel-2. So as you can see, Sentinel-2 can give us a better representation of the areas with water on it. And we can change the color so we can observe them in a different color. This one we can change to darken. And that's how we can compare the flooding areas that we obtained with Sentinel-2 and with Landsat 8. So you can do this exercise with the input data, but we recommend that if you are downloading the satellite images, you apply the atmospheric correction, because as you saw, we have the, for instance, with Landsat, we have the area with clouds. So if you apply the atmospheric correction, maybe that can help you to get better results. And you can apply the atmospheric correction by going to the SCP plugin and then you can go to the preprocessing option and apply the DOS1 atmospheric correction. you input your bands, and then you apply the atmospheric correction. And I hope this tutorial was helpful for you. And now you can know how to determine flooding areas using the NDVI of different satellite images, and that Sentinel 2 can give you a better resolution than Landsat 8. If you like this tutorial, please like it and share it. I'll see you in the next tutorial. Bye.